Hi everyone. Today we're going to study propositional function. There are statements that involve variables. Examples: x is greater than 3, x equals y plus 3, x plus y equals z. Computer X is under attack by an intruder. Computer X is functioning properly. These statements are neither true nor false when the values of the variables are not specified. We have here one example: x is greater than 3. In this example, we have two parts. The first part is the x, and we call that the subject. The phrase is greater than 3 is called predicate. Now for the notation, we write capital P of x, and we call this now the propositional function, where P denotes the predicate is greater than 3, and x is the variable, or we say the subject. The statement capital P of x is also said to be the value of the propositional function P at x. Once a value has been assigned to the variable x, the statement P of x becomes a proposition and has a truth value. Example 1. Let P of x denote the statement x is greater than 3. What are the truth values of P of 4 and P of 2? In this problem, we write the P of x, colon, x is greater than 3. Now let's begin with P of 4, meaning we will substitute this value 4 to the x on the right. So we have 4 is greater than 3. We know that 4 is greater than 3, and that is true. So the truth value for P of 4 is true. Now for the P of 2. We substitute the number 2 to the x. So we have 2 is greater than 3. And we know that this is false. So the truth value of P of 2 is false. So we have now the answers. P of 4 is true, P of 2 is false. Example 2. Let capital A of x denote the statement computer X is under attack by an intruder. Suppose that of the computers on campus, only CS2 and Math 1 are currently under attack by intruders. What are truth values of A CS1, A CS2, and A Math 1? Let us write the given. A of x, colon, computer X is under attack by an intruder. Let's begin with this A CS1. So we substitute this variable x by the computer. So we say that computer CS1 is under attack by an intruder. Because CS1 is not on the list of computers currently under attack, we conclude that A CS1 is false. Since CS2 and Math 1 are on the list of computers under attack, we know that A CS2 and A Math 1 are true. Example 3. Let Q of xy denote the statement x equals y plus 3. What are the truth values of the propositions Q12 and Q30? So we write the given qxy colon x equals y plus 3. Let's begin with q12. So the number 1 corresponds to x and the number 2 corresponds to y. We substitute respectively, so we have 1 equals 2 plus 3. Simplifying the equation, the right side becomes 5, and we say that 1 is not equal to 5. So the q12 has the truth value false. Next is the q30, and this is equal to the 3 equals 0 plus 3. When we simplify, 3 equals 3. So this is true. We know now the truth values of the propositions. q12 is false, q30 is true. N-ary predicate. In general, a statement involving the n variables x sub 1, x sub 2, x sub 3 up to x sub n can be denoted by p of x sub 1, x sub 2, x sub 3 up to x sub n. A statement of the form p of x sub 1, x sub 2, x sub 3 up to x sub n is the value of the propositional function p at the n tuple x sub 1, x sub 2, x sub 3 up to x sub n. And p is also called an n-place predicate or a n-ary predicate. Example 1. Let R of x, y, and z denote the statement x plus y equals z. What are the truth values of the propositions R of 1, 2, 3 and R of 0, 0, 1? Let us write the given, the R of x, y, z, that is x plus y equals z. Now let's evaluate R of 1, 2, and 3. Remember, the number 1 corresponds to the x, the number 2 corresponds to the y, and the 3 corresponds to the z. Let us substitute the corresponding values on the equation. So we have this 1 plus 2 equals 3. Simplifying the equation, the left side becomes 3, and that is equal to 3. So the truth value of this R of 1, 2, and 3 is true. Let's go now to the R of 0, 0, 1. Substituting the corresponding values, we have now 0 plus 0 equals 1. Simplifying this equation, the left side becomes 0 equals 1. This is false. So the truth value for R of 0, 0, 1 is false. Example 2. Consider the statement, if x is greater than 0, then x colon equals x plus 1. When this statement is encountered in a program, the value of the variable x at that point in the execution of the program is inserted into p of x, which is x is greater than 0. If p of x is true for this value of x, the assignment statement x colon equals x plus 1 is executed. So the value of x is increased by 1. If p of x is false for this value of x, the assignment statement is not executed. So the value of x is not changed.